Okay, so let's learn about mean value theorem. Mean value theorem, also called MVT, is when f of x is continuous on an interval from a to b and differentiable on an interval a to b. Mean value theorem says if those two things are true, if f of x is continuous and differentiable, then there's at least one value called c in the interval a to b such that f prime of c equals f of b minus f of a all over b minus a. Now, the theorem, when I'm looking at it here, reading it to you, this is the most important part down at the bottom here. It says the derivative equals f of b minus f of a all over b minus a. And I'm going to show you what that means. I'm going to make probably 5 comments on this theorem a little bit, but the key thing is this. It has to be a continuous function and differentiable. That means there's no kinks, no holes, no asymptotes, nothing weird. So, let's make our 5 comments. Comment number 1. Comment number 1 is this. At x equals c, this means the average rate of change equals the instantaneous rate of change. And what I've done is I've made a graph down here, and I'm going to show you what this theorem says. The theorem says that if you have a point at A and some point at B, there are 2 things the function has to be. It has to be continuous and differentiable. So there's no kinks, there's no holes, no asymptotes. So I'm going to write that down here. Nothing weird. No kinks, no holes, no asymptotes. So I'm going to connect this A to B with a graph that has no kinks, no holes, no asymptotes. So it can be anything I want to connect it with. So let's go for something really simple, like just like a curve. And this is the graph of f of x. Well, here's what the theorem is trying to state. There is a point called C, somewhere in the middle from A to B, well, anywhere between A to B, where the average rate of change equals the instantaneous rate of change, which means average rate of change is a secant line. If I was to make a line from A to B, this line right here is my average rate of change. So I'm going to write that down here. That's my average rate of change line. And somewhere on this interval, there is a spot where the instantaneous, which means the tangent line, is about the same. So right around here, if I made a tangent line, notice that the tangent line and the average rate of change line are parallel to each other. They have the same slope. So here is my instantaneous rate of change line, my tangent line, and they have the identical slope. They're parallel to each other. That's what mean value theorem is saying. If a graph is continuous and differentiable, there's got to be a point called C. So C is really not, let's erase this. This does not make sense. C is going to be wherever the point is. This right here, that's C. So that looks a little messy, but C is going to be wherever the point parallel to the average rate of change is. So, okay, so that's comment number 1. I hope that makes sense. Comment number 2 is this. There may be more than one place, one value, where the derivative equals the average rate of change. So you know how we had that graph earlier from A to B? I'm going to put a graph down here again. Here's A, and B is at some random point up here. And remember, there can't be any kinks, holes, or asymptotes. There can't be any of that kind of stuff. So I'm going to connect and make a graph. Maybe this time when I connect and make this graph, I'll make it a little more interesting. So maybe something more like this. Now when I start saying that the average and the instantaneous rate of change are equal to each other, the average rate of change is the line that goes from point A to point B. So that line, I'm going to make it dotted. That's my average rate of change line. Well, f of b minus f of a over b minus a, this thing, that's the slope of that dotted line. That finds the slope of that line. So, there is now, in this graph, a whole lot more going on here. If I found a tangent line at the top of this peak here, or this edge of this graph, I'd say it's probably parallel. And if I found a tangent line somewhere over here, I would say that's probably a parallel spot also. So this is a case where we have 2 C values. This is my C here. I say this is C1, and this is probably point number 2, C2. And it turns out that if I found the derivative at C1, it has the same slope as the derivative. It has the same derivative as C2. And both of these equal the average rate of change, which is f of b minus f of a all over b minus a. So often you can have more than one point where this is true. So that's comment number 2, that this can happen more than once. Comment number 3, the word mean in MVT, mean value theorem, refers to the mean average. So when we're saying mean value theorem, you're thinking average rate of change theorem. It's an average theorem. So it's all about saying that the instantaneous and the average equal each other. Comment number 4, MVT is probably one of the top 2 theorems in calculus. It really is. It's definitely one of the top. So we're going to use MVT a lot more later in the year as we start learning second semester concepts, but I want you to have a good handle of it now, that the function has to be continuous and differentiable, and that the average equals the instantaneous rate of change. I really want you to have those ideas down. Comment number 5, MVT is an existence theorem. So it says a value C exists, but it doesn't necessarily tell us how to find it. Sometimes you can never find this point called C. Sometimes you can. It just depends. So an existence theorem, kind of like intermediate value theorem and extreme value theorem, IVT, EVT, all these theorems don't necessarily find the point. They just tell you that one exists and it happens to be at a certain spot. So we're going to apply, I need to fix this existence, there we go. We're going to apply this theorem and try a problem. So this is what's going to be on kind of like your worksheet in your homework. It says find all values of C which satisfy MVT for f of x equals 5 minus 4 over x on the interval 1 to 4. So we want to find all values where the instantaneous rate of change equals the average rate of change. So this is kind of like our A to B from 1 to 4. So when I look at this, I'm thinking, you know what? I have to find a time when f prime of C, some number, is equal to f of b minus f of a all over b minus a. So I need to break this problem up into a couple of steps here, starting with what is f prime of C and what is f of b minus f of a. So first off, let's find f prime. And when we go to do this, I'm going to do it over on the side here. We're going to find f prime of x, find the derivative. 5 minus 4 over x, this is the thing I want to derive. Well, you might want to rewrite it. You might want to change that 4 over x to be, let's change this. How about 4x to the negative 1? So it's easier to power rule. So my derivative, when I power rule it, is going to be negative 4 times negative 1, x to the negative 1 minus 1. So this is going to be positive 4x to the negative 2 power. Or I could say positive 4 over x squared, like that. So this piece, f prime of C, is going to equal 4 over x squared, but instead it's going to be c squared. 4 over c squared. That's my derivative at C. We're going to set it equal to f of b minus f of a all over b minus a. So we need to figure out this next. So let's make some space here. I'm going to delete some of this work so I have a little more room. Now we want to find f of b minus f of a. So we're going to do f of 4 minus f of 1 all over 4 minus 1. Which means I need to plug 4 and 1 back into my original equation. So I need to plug 4 back into 5 minus 4 over 4 minus, plug in 1, 5 minus 4 over 1 all over 3. And we're going to clean this up. And if you clean this up and do the math here, it should clean up to a decent number. Let's see, let's plug it in here. Actually, it cleans up to be 1. That's not bad. So, if it all cleans up to be 1, what we're going to do is go back over here and say, okay, now f of b minus f of a over b minus a is equal to 1. So we have 4 over c squared equals 1. which means let's solve this thing. Let's cancel the c squared and multiply it over here. 4 equals c squared, and we'll take the square root of both sides, and we'll get c equals plus or minus 2. The square root of 4 is 2. And then we'll go back to the question and say, what were we supposed to figure out? We were supposed to figure out what values of c satisfy the theorem from 1 to 4. So 1 to 4 means c equals positive 2 can be the only answer that fits the interval. And that's it. And what that means is if you go to 2 on the graph, the tangent line is going to be parallel to the secant line from 1 to 4. The average rate of change is going to equal the instantaneous rate of change. So, you try one. Pause the video and give this a try. Find all values of c which satisfy MVT for f of x equals x squared plus 2x minus 1 on 0 to 1. You try it. See if you can get it right. Okay, so remember this is what we're going to do. We want to find f prime at c, and we want to set it equal to f of b minus f of a all over b minus a. We want to know where are these equal to each other. So we're going to go over to the side here, and we're going to start by finding f prime of x, the derivative. And the derivative of this thing is just a power rule problem. It'd be 2x plus 2. And we're going to change that to be c's, because we want f prime of c. So we're going to write 2c plus 2. Then, once we figure that out, we're going to go to the next step, which is figuring out f of b minus f of a. Except a and b are 0 and 1 in this problem. So we're going to do f of 1 minus f of 0 all over 1 minus 0. And clean that up. And we're going to plug 1 and 0 back into the original equation. So we're plugging 1 and 0 back into f of x, back into this thing. So when we plug it in, we get 1 squared plus 2 times 1 minus 1, minus, we'll plug in 0. 0 squared plus 2 times 0 minus 1, all over 1. And so we just got to clean all this up, get an answer. And if you clean everything up and figure out what this fraction is equal to, you should get 3 over 1, so 3. So, now that we know that's 3, we know that f of b minus f of a is 3. We're going to set them equal to each other, and we're going to solve for the letter c. We're going to subtract 2 from here, so that 2c is equal to 3 minus 2 is 1. We're going to divide by 2 on both sides, and we're going to get our final answer is c equals 1/2. So the value of c on the interval 0 to 1 is 1/2, right in the middle. So to kind of recap, a little bit of a long video here, but the main idea behind this, going back to kind of the start, is that mean value theorem says there has to be one spot, at least one spot on a graph, where this average rate of change, where you connect the line between the 2 points, is equal in slope to the instantaneous rate of change, equal to the tangent line slope. They're parallel to each other, and there's got to be at least one spot, and that only works if there's no holes, no kinks, no asymptotes. It's got to be a continuous differentiable function. That's what MVT is all about.